Good morning, my name is Zane Hemmer. I'm currently an electrical engineering student here at Arizona State University. I'm part of the FSC 100 Final Boss engineering team. Today we'll be introducing Test Tube TED, getting right into introductions here. Test Tube TED is designed as a compact box-shaped robot with wheels that follows a marked path on the hospital floor. Its main feature is a single drawer on the front where staff can place test tubes and small samples. The drawer closes with a basic latch to keep items secure during transport. For navigation, TED uses infrared lines following sensors that allow it to stay on simple black line tape for the hospital floor, leading directly to the lab. Once it arrives, the drawer automatically slides open using a small servo so the lab staff can access the samples quickly. This robot is essentially simple, with one storage space and a basic sensors, make it reliable and affordable for the smaller hospitals. Getting right into the CAD design here, very basic design, more of a cart shape. Plenty of storage, a lot of drawers, and a big cabinet on the bottom there. We have a dome with a servo that opens and closes that holds our certificate holder for our test tubes, and a desktop where nurses or any type of personnel can input, output data there. Getting right into the test tube TED wiring here, legend-wise, red is power, black is common, blue is signal wire. We have a green and yellow analog wire as well. And for components, we have one ultrasonic sensor, we have an L293D motor chip, two DC motors, one servo motor, we have an Arduino. We have an IR scanner plus remote, we have a push button, two breadboards, and a 9-volt battery. Kind of getting into more of the pins and connections here, all power is kept all grounds. Arduino 5-volt wise, we're powering an ultrasonic sensor, an IR receiver. We have and a 7-segment display. We have that all grounded there. Battery wise, we are powering pin 8 on the VCC2 on the motor chip, as well as a servo motor. We do have pin 16 on that motor chip, powered by 5 volts. Enable 1 is digital input 2, input 1 is digital input 9, output 1 and 2 on that chip is going to motor 8, terminal 1 and 2, input 2 is digital input 10, enable 2 is going to be digital input 13, enable 3 is going to be digital input 5, and for output 3 and 4 going to motor B, terminal 1 and 2. Input 4 is digital input 6, and pins 4, 5, 12, and 13 are all grounded. Pin 8, which is VCC2, which we discussed, that battery is powering that, and pin 16, which is VCC1, is powered by 5 volt from an Arduino. Ultrasonic sensor wise, the trig pin D4 is the connection there. Echo is going to be D7, and also powered by 5 volt from an Arduino. Servo is going to be digital input 3 and powered from the battery of 9 volt. And the push button is going to be digital input 8 and also grounded there. The IR receiver remote has digital input 12, powered by the Arduino, and the 7-segment display has an analog 4, the SCL analog 5, and a line sensor, which is analog 0. So kind of getting more into the actual design here. We do have it simulating already. You can see that we have RPMs on our motors on both. We are moving, but based on the sensor here, so maybe under around, when we get to more 80, kind of getting down to the 60 range, it's going to have a stop on our IR scanner here, and we have no RPMs on our motor. So kind of getting into that, we do have it stopped, and once it is stopped, if a nurse or a doctor wants to open up the robot or the servo lid, all we do is simply press this, which kind of, another thing to kind of point out here on our serial, you could see that we have the state run, motors are off, we have a certain distance here that the ultrasonic sensor is reading, we have the IR intensity, and right now since we opened up the servo, it is saying it's open. And why? Because we are stopped, we're waiting for a clear distance. So let's say if we wanted to close the lid, right, we're going to go ahead and close the servo here. There we go, and you can see that we do have the lid closed, and if we kind of push up here and getting into a good distance, our RPMs will kick back up and our path is clear, as you can see in the serial. Kind of getting into the code a little bit, we do have a bunch of comments just kind of labeling out what is what. We do include our wiring, our remote, and our servos, our options. We have all our pins, analog line sensors, behavior and tuning, our lid angles for opening our servo, our IR code, button code, our segment helpers, motors, ultrasonic code. We have a robust button to bounce. Let's see here. Sensor reads our motion decision based on what is going on and how it outputs that, and our SIL dashboard every 5 milliseconds. So basically, yeah, that's kind of our code, and thank you for our time. You have a great day.